this is only valid for constant A. So what we're going to do from now on is only valid only for A constant. So if A is not constant, can I use this? So what is going to aspire in the next 20 minutes is going to be me deriving equations that we're deriving about 4 equations that would tell us how to describe, predict where an object is, how fast it's going, and so on and so forth. And remember, when I say velocity and acceleration, I mean instantaneous velocity and instantaneous acceleration. So based on that, since A average is defined as V final minus V initial over T, and because we have constant acceleration, then this also equals the instantaneous acceleration. Right? That's the whole condition. The whole condition is A average equals. Good? Are we all in agreement? So if that is the agreement, then I could say that A equals V final minus V initial divided by T. And since I don't like division, I would like to rearrange this equation. Does that make sense? So if I multiply both sides by T, this would be A times T equals V final minus V initial. And if I want to write an equation down that could predict my final velocity, my equation is going to look as follows. V final equals V initial plus A. Cool. What this equation says that if you give me what you started with and your acceleration and how long you traveled, I will tell you what your velocity now. Meaning if your initial velocity was 3 meters per second, your acceleration was 1 meters per second squared, and after, let's say, 12 seconds, how fast were you going? Can you know? And the answer starts with
15 meters per second.
So you don't have to guess, you just write this equation down, apply it, and there you go. But before you apply it and do anything in this regard, you need to remember that these are vector quantities, and I need to identify right or left, positive or negative. That all depend on you. Correct? Maybe not.
Sure. Yes.
So I'm going to go like, let's assume who's the lucky person. Remind me of your name?
Bridget.
Bridget. So Bridget, in Bridget's universe, how things go? No.
Come on, Bridget.
Let's
Make it
assume this is what everybody will call normal. Okay, in Bridget's universe, if you're moving right or left, so based on this, 3 meters per second, 1 meter per second, 12 mean moving right. So if I want to find the final velocity, it's going to be the initial velocity plus acceleration multiplied by time, which gives me initial velocity is 12. No, sorry, what was it? 3. And it's positive because they told us it's positive. Acceleration is 1 because they told us it is, and time is 12, and that gives you 15 meters per second. See, this is kind of. Now, you will also find out that if you have constant acceleration, then the average is going to be V final plus V initial divided by 2. So if you guys could remind me of the example we had. We started with what velocity? I forgot. V1 was 5, V2 was 8, right?
Yep.
V3 was 11, V4 was 14, correct? Let's find the average of these numbers. What is the average? It's going to be 5 plus 8 plus 11 plus 14 divided by 4.
9.5.
Good, 9.5. I also would like to find what is this? What is V1 plus V4 divided by 2? Which is 14 plus 5 divided by 2, which is? Cool? So this statement is accurate. Are we good with that? So based on that, V average, and we also could say that X, that displacement also could be written as the average multiplied by T. Meaning assuming there's no acceleration. So based on that, I could expand this equation to say, if I don't want to have any average velocities, since we are only dealing with initial and final or instantaneous, I could write the average as 1/2 V initial plus V final times T. So this is equation number 2. This is equation number 1. We have now derived 2 equations. If you give me initial velocity, final velocity, and time, I could tell you how far you traveled. If you give me X, V initial, and T, I could tell you V final. So on and so forth. So far, we have managed to derive 2 equations. There are 2 more to come. If I take that equation, which is X equals 1/2 V initial plus V final multiplied by T. What if I want to get rid of V final? Can I do that? Guess what the answer is? Starts with a Y.
Yes.
Yeah, we can. So the way I'm going to do this, I know what V final is. I could substitute, instead of V final, that quantity. Can I?
Yes.
Yeah.
Of course I can. So X, yeah, math allows it. So instead of V final, I'm going to write V initial plus A T, and the whole thing is multiplied by T. And then I'm going to be patient, and I'm going to multiply T with the whole thing. Can I do that?
Yeah.
So that would be V initial T plus V initial T plus A times T times T is T squared. And now V initial T plus V initial T gives me 2V initial T. So all of that goes away. I'm going to write 2V initial T. And then I'm going to multiply the 1/2 by the whole thing. 1/2 times 2 is?
1.
So that would give me V initial T plus 1/2 A T squared. And there's another formula where I don't need to know the final velocity. I need to know acceleration time and initial velocity, and that would give me the results. And finally, can I get rid of T? Can I find a formula that does not have time in it?
Sure.
Absolutely.
And that's what we are going to do